Hello and good morning. Welcome to this session on robotics for safer nuclear operations and decommissioning. My name is Chris Ballard and I'm the Programme Manager for Robotics and AI at Sellafield in the nuclear industry. I'm being co-chaired today with...
And I'm John Patrick Richardson. I'm Robotics Development Lead at National Nuclear Laboratory, and I'll work alongside Chris in the Central RAI programme at Sellafield.
Thanks for that, JP. So we've got 7 action-packed videos for you to see this morning, presentations all about products and projects that have been developed to assist us within the nuclear industry. Within the nuclear industry, as I'm sure you're aware, things are slightly different with a lot of risk and a lot of hazard attached to the projects and the programs that we've got within our decommissioning challenges going forward. To help us to do this and to help to provide that interface between our robotics and our extreme environments, we rely on innovation such as these projects to help us to achieve our goal of keeping our workforce safe, but also to continue our successful mission delivery through to decommissioning. So without further ado, I'd like to introduce the first of the presentations, and this will be by Peter Outledge from the 4th Engineering Supply Chain, and he'll be discussing the A2I2 project.
So I've been involved in this programme for about 2 years now, and one of the things I wanted to see was that this capability can define a point of interest. So for instance, on our legacy ponds, we have to decommission, remove inventory. So it'll be really useful for us to be able to define a data set, and then for us to actually survey and prove sort of accountability that we've got those items retrieved and that they're able to be sentenced out from the pond.
What we've seen so far with the technology and the way that this technology is advanced is absolutely fantastic. It just shows that we've got a very capable supply chain, with some real clever people out in the supply chain willing to help us satisfy our challenges, so it's encouraging. The benefits for us back within Sellafield is we need to look at removing operators from these harsh environments. Typically things are done through teleoperational controls. What we're seeing demonstrated here is the potential for autonomous processes where we can map live environments, we can see what's going on in our harsh environments, but not only that, it's got the collision avoidance systems built in and the communications that we so desperately need from down within the pond. So I think it's tackling a lot of different discrete areas for us to utilise within the business.
It is exciting. I've worked on other programs with other companies, and this is the furthest we've got towards achieving the requirements we need for not only inspection intervention of items that we have within our facilities, but also taking that technology wider, not only within Sellafield Enterprise, but also it's the NDA estate, it's the wider piece across the UK sort of nuclear programmes as we move into decommissioning.
And our next video is from Professor Rustem Stolkin at the University of Birmingham, and he's discussing the work of the National Centre for Nuclear Robotics Hub.
My name is Rustem Stolkin. I'm Chair of Robotics at University of Birmingham. I'm also Royal Society Industry Fellow for Robotics, part embedded with the National Nuclear Lab Limited, UK. I'm Director of the National Centre for Nuclear Robotics, and I'm also the Chair of the Expert Group on Robotic and Remote Systems for the OECD's Global Nuclear Energy Agency. The National Centre for Nuclear Robotics was founded in 2017 with a £14 million grant from the Industrial Strategy Challenge Fund, originally a consortium of 8 universities. Via our Flexible Partnership Fund, we expanded to include 12 research institutions across the country from Scotland down to the south coast. In the first 3 years, we produced well over 300 peer-reviewed papers. In addition to robotics and AI and associated engineering, we also expanded to the humanities, political and social sciences, and issues of management, regulation and policy. We've delivered a very large number of world-first landmark deployments of robots on nuclear industry sites in the UK and internationally. We've also had impact across a number of other industrial sectors, and we've undertaken significant international leadership in EU robotics and also with the OECD's Global Nuclear Energy Agency. The past 3 years has seen the creation of a number of very significant robotics installations. Currently, world-leading work on fully autonomous grasping and manipulation of unknown objects of arbitrary shapes from random heaps using computer vision. Another way that we can augment computer vision is with tactile sensing. Here on the right, you can see a robot feeling its way around a hexagonal bolt using its torque sensors to perceive shape. And on the bottom right, you can see that it's successfully reconstructed the hexagonal shape of the bolt head. On the left, you're seeing a very advanced dexterous hand with tactile sensor arrays, and it's making successive tactile glances of an object to gradually improve its understanding of the object shape, but at the same time it's also simultaneously refining its grasp pose to find the most robust and secure grasp while it's also exploring. So just to reiterate, we've been doing this for real. So top right is the first ever deployment in history of a autonomous AI controlled robot arm in a radioactive environment. This is work that University of Birmingham did with National Nuclear Lab at the Preston Springfields nuclear plant, laser cutting contaminated steel. And this is using AI autonomous grasping as an operator assistance technology to aid a human during teleoperation. And on bottom left, you can see this being deployed at National Nuclear Lab's Workington site in Cumbria, controlling very heavy duty industrial manipulators. And this is a nuclear industry worker testing the system out. And this is being deployed under full nuclear safety regulation and national security regulation.
Brilliant. Thanks for that presentation there, Rustem. As you can see, that was a fantastic overview of what the work they're doing within the NCNR Hub. So the next video the next presentation we'd like to present to you is from Matt Miller, who is the CEO at Createch. And his is the Radiation Center Intelligent Nuclear Robotics. Over to Matt.
So what we've tried to do in this specific project is to make a subsystem, a reusable subsystem that is packaged, a detector with some autonomy that converts the very specific data and the subjective data that comes out of that specific detector into something which is objective and sufficiently abstract that a robot can deal with it without needing to know precisely how that specific sensor was used to produce that specific result. What that means is that someone who doesn't necessarily understand how radiation measurement works can still take this system and integrate it with their robot to get some specific task complete, and they can be sure, and their end user can be sure, that the computations behind that are robust and that the robot is achieving its specific quality objective, rather than simply going and getting some data which may or may not turn out to be sufficient when we analyze it.
Thank you, Matt, and thank you for that video from Createch. So next up, we will have John Brotherhoods from Jacobs, and he'll be introducing the work of the SBRI project, the Integrated Innovation for Nuclear Decommissioning.
The decommissioning of nuclear facilities is the liability faced by all nuclear sites at the end of their life. There is a global need to reduce the costs and improve the safety of these activities. And in 2017, the UK Nuclear Decommissioning Authority challenged the supply chain to come up with new ways to address this challenge through the Integrated Innovation for Nuclear Decommissioning competition. The competition was run by Innovate UK and was funded jointly by the Nuclear Decommissioning Authority, Innovate UK, and BASE via the Industrial Challenge Strategy Fund. Jacobs accepted the challenge and developed a solution which used disruptive technology to reimagine the process. These came together as a modular toolkit which used wireless and battery technology to enable rapid customization and flexible deployment. New instrumentation was combined with modular data-centric systems to create a faster and more agile process. Jacobs led a diverse consortium of 10 organisations, including 5 SMEs, academic and industrial suppliers. And the complex 2-year project involved the integration of novel technologies across all organisations. These were developed and proven using both physical and virtual testing. The project concluded with a 5-day independently assessed showcase that took place in Jacobs facilities. The Jacobs Consortia was the overall winner of the competition. We received excellent feedback on our ideas and implementation and project delivery from the assessors. As a result of our success, we've been awarded a contract to test our ideas on the Sellafield site in a real decommissioning scenario. We've developed strong relationships with our SME partners and have identified and secured new opportunities to apply these technologies across multiple sectors. The project itself was recognised by Jacobs in their internal innovation awards in 2020.
And thank you for that, John, for giving us some insight there on the programmes that you're doing within Jacobs. Very interesting. We'd now like to hand over to Professor Barry Lennox, who will give an overview on the Robotics and AI for Nuclear Hub.
The Rine Hub was established in 2017 to translate technology from academia into real industrial settings. Naturally, a key part of that is industry engagement. We have always been keen to share our research and deployment aims with real people from end-user organisations and the nuclear supply chain to identify challenges and align our programme of work accordingly. It's great to share what our technology and techniques are capable of and find out what we should investigate next. The support, questions and critique are always welcome as it helps us create better solutions. We are enormously grateful for the support we have received across industry so far. Of particular value is the help in developing specifications, success criteria and providing test environments which then support deployments and ideally commercialisation. We have held in-person events to showcase our technology and understand more about robotics challenges. Phase 1 of RAIN focused on remote inspection and remote handling tasks alongside safety case development. Phase 2 of RAIN expands this focus to include human-robot interaction and standardisation. Additionally, we plan to extend our engagement with our non-nuclear network to invigorate nuclear solutions, as well as add value into sectors beyond nuclear. Industry engagement doesn't end at workshops. We have carried out many collaborative projects with the supply chain to link RAIN technology into developed or developing products. This allows us to add value much more quickly and accelerate our research plans while helping suppliers improve their product offerings. By using the feedback from events and collaborations, we refine our research and improve our technologies. We also get to meet fantastic people. We are always keen to keep conversations going. In April 2020, we launched the RAIN webinar series, which allows us to share our findings as well as give a platform to our fans for them to share with the community too. Industry-facing, lab-based demonstrations of RAIN capability are wonderful markers along the RAIN programme that display our progress so far and show we have a grasp of the challenges. Of course, we want our robots to earn their keep by getting them out into the real world too. Via the RAIN working groups, we focus on multi-technique, multi-technology deployments to show the value of robotics in industrial settings. Preparing our technologies, building working relationships and deploying kit on site all helps pave the way for a time when nuclear robotics is considered an everyday task. Our demonstrations so far have shown the power of academic and industry collaborations. We have shown some of the enhanced capabilities that robots possess compared to humans in similar settings. By deploying RAIN technology, we aim to create excitement and enthusiasm while providing a genuine benefit to people who are dealing with working challenges. Drawing on our international industry engagement, we have deployed equipment beyond the UK And in phase 2 of RAIN, we are excited to share what we can achieve next with your help.
And thank you, Barry and the Rine Hub, for that video on their work. Next up, we have a video introduced by Rory Dobbs from Barnon, and they'll be talking about the ConnectR project.
Hey everyone, and welcome to ConnectR, providing structure in unstructured environments. So I'm Rory Dobbs, the project manager for Barnon and the project lead for the ConnectR consortium.
And I'm George Sewell, the design lead at Barnon and the lead designer for ConnectR itself.
So what does ConnectR solve? It's an industry problem and it covers the nuclear sector, oil and gas and space, and it's mainly around contaminated areas, remote locations, hazardous weather and inaccessible locations where there's a danger to life and structure is required.
So one of the key use cases that we identified for this would be in some of the Hanford tanks in the USA. Now there's 177 of these storage tanks, and imagine if one of these was leaking. There'd be no other way to get in there and repair a patch on a sidewall. So this is one of the things that we're going to focus on during this presentation. So you can see here a graphical representation of the inside of one of the Hanford tanks. You can see that we can scan the area, and then we can build a structure to the edge of the tank. And the structure would be a bridge-like structure in this case. There's another robot could then walk along and perform a task.
So this is planned using artificial intelligence and symbolic planning. This then we've got a graphical user interface which provides us with the most efficient route and what moves we'll be making in the physical environment.
So we produced various prototypes during this project. This one's showing the knuckle actuating and then it performing one of the key building moves. The robot here has got various high-tech components that were invented for this project, including genderless connectors that allow the project to be, or the product to be built. We've got really dense hydraulics, and one of the key challenges with this project was to use a hydraulic system in a very small space to enable us not just to prove that self-building robots are possible, because we've seen that with other smaller electronic devices, but to prove that we could make a self-building robot that was capable of performing industry tasks. So this thing is super strong, it's driven by hydraulics, it's able to operate in really harsh environments because of that, but that did lead to lots of design challenges where we've had to make our own miniature valving, we've had to look at how to fit this stuff within the space that we've got, and a lot of other novel and innovative technology has gone into the production of this.
Well, thank you for that, Rory, for giving us that insight from Barnon on the ConnectR project. Very good information there. So the final presentation is from Professor Rob Buckingham from RACE, and he's going to be discussing the Long Ops project.
And thank you once again to all the organisations providing those videos. Now we're going to move to a Q&A panel. So I'd like to invite all the representatives from those organisations to join us now. So our first question is going to be for Professor Barry Lennox from the Rine Hub. And Barry, I'd just like you to explain, what do you feel is the best way for an industry partner to engage with a robotic hub like RAIN?
Right, so one of the main things we're trying to do within these hubs is to provide that link between academia and industry. So it's really important for us that we do engage with industry. We've had about 50 industry projects since RAIN began 3.5 years ago. So we are very keen, and we would like to do more. Probably the easiest ways is to get in touch. If you go to the RAIN webpage, and NCNR will have similar webpage information. Ours is rainhub.org.uk. That will explain to you how you can get in touch, but it also has descriptions of some of the robotics technology that we've been developing. And for each of those robotic technologies, it will tell you where what TRL we're currently at and what we're looking for in industry support. So I just encourage people to take a look at what we're doing, see if it's relevant to them, and try to get in touch if they think they can help commercialize and progress some of the technologies that we've got.
Very good, Barry. I wouldn't mind asking the same question to Rustem, if that was okay, just to get the other hub's perspective on that. If Rustem's okay to answer that one for us.
Yes, so I mean, the hubs are essentially collections of academics doing research, but all of this research is very much dedicated to industry challenges. There are a variety of ways to get involved. We can get time of one of our postdoc researchers working on a particular problem that your company has, or we could move to working with PhD students or these kinds of things. So there's a big network with a variety of different experts in different technologies available who are keen to dedicate their efforts to industrially relevant challenges.
Thank you, Rustem. And one I'd like to include for John Brotherhood, if that's okay, and that is to ask you the question: what do you perceive to be the role of the regulatory framework in nuclear decommissioning in enable and/or accelerating the absorption of robotics in the sector?
Well, thanks, Chris. The regulatory framework is a really important part of this whole discussion, really, and they serve a very important role. They're there to protect the workers, the environment, the public from radiological harm, and basically to sort of act as the checks and balances on what the industry does. And there's a very structured framework in place. Now, looking at the robotics does take us into a place where the regulator is walking into new ground and they're having to do stuff. But it's on all of us to do it, is to show that these technologies firstly are safe, but also that they bring safety benefits over how we're currently doing that one. And that I'm seeing through my own experience, through what's going on in the RAIN hubs where I've been involved and working with those, where the regulator has got involved as well. Fantastic conversations going on across the industry, from the regulator through to the site license holders and developers and the academic community, looking to try and find the way through this. And I think it's developing a really positive story, but there's a lot of work to do in that area.
So I think you're right with that, and I completely agree with that. Our sort of interactions at the minute, the regulators actually open the door, haven't they, a lot to this, and they're very much embracing what we need to do as part of the next chapter for keeping people safe. That's fantastic. Okay. JP, do you have the question?
Yes, next question we'd like to ask of Peter Routledge at Fourth Engineering. Just, Peter, what do you perceive to be the most critical barriers in commercial engagement in this sector, and what do you think could improve engagement of innovative companies with end users?
I think one of the challenges from an SME perspective to gain contracts and work with Sellafield is some of the processes. Most of the funding allocated now for SMEs comes through a proposal or a bidding process. And whilst in the supply chain, you've got a lot of innovation companies, but not necessarily have the bid writers within the organisation. So a lot of the SMEs or the small supply chain companies have actually got the technologies and the innovations to support Field on a lot of their challenges. But due to the processes of actually writing an application form or a process, inhibits some of the smaller supply chain companies from actually working direct with Sellafield. And as a consequence of that, we need to collaborate more with the tier 2 partners or the larger businesses within the supply chain. and that takes the edge away and the dynamic proposal away from the small SMEs. So I think that's one of the major challenges SMEs and support them on some of their major challenges at the moment.
Very good. I think we're worth asking as well, Matt, from Createx perception, is that very much synergies there with yourself?
Yeah, so reiterate everything Peter said. I mean, I think we find that there's two things that are absolutely critical where we have been successful, and those two things are, first of all, you need some way to be able to lead action from the outside. So you need to be able to make unsolicited proposals, or other ways to stimulate action. And of course now, taking Sellafield as a specific example, we've got the game changers process, which allows you to do just that, and we think that's been a big step forwards. And the other thing that makes a real difference is pace. Regardless of what the processes are, it does take quite a long time in between completing an R&D project and then moving on to the next phase. We're typically finding between 1 and 2 years in the UK for that process, whereas in Asia it might be more like 3 months. So we're often finding that tends to attract our attention to those areas. Not that that's a bad thing, but of course we don't want to sort of miss out on the opportunities that exist domestically as well.
That's really good, Matt. And what about yourselves, Rory, from bar none? Do you feel the synergies there with yourselves when interacting, especially with commercial avenues?
Yes, I would agree with what Matt says there. Going off the game changers, that process is really working well for us and is really interactive with you guys. We both learn from each other, and I think we can really direct our proposal where it needs to go. However, I would agree that the going to the next phase and taking it forward, that times, especially for SMEs, it is quite a long process. Whilst we're eager to get going, but the paperwork and the other processes are kind of slow in progress slightly.
Great, thanks Rory. We have a question from the floor for Professor Rob Buckingham at RACE. So question for you, Rob, is how will industry, and in particular startups and SMEs, be able to engage and join long ops projects?
Okay, great question. So one of the things we set out with long ops was that we would spend more than 50% in the supply chain. So we fixed that target from the very outset. It looks like we're going to be much closer to 65. And basically the way to engage is to go onto the UK AEA's contract finding website. All the information is there. If you can't find that, then you're welcome to ping me an email or one of my colleagues, and we will make sure that you get to the right place. So it's an open, transparent process, as are all of the public procurement pieces. And so you need to be in that system and go through the process. And that very much links to the comments from colleagues in the SMEs just now. That we know it is hard for government organisations to procure. We are under a lot of oversight regarding that process. We try really hard to make it as fast and as painless as possible, but we often fail. So it's something that I'm very aware of, and we're trying to work out what to do.
Brilliant, thanks, Rob. There's another question come from the floor. I'd like to direct this towards the academics, if that's all right. So Barry, we'll come to you first, and then Rustem to yourself. And this one's asking about the robotic systems that has been developed. So they're saying that the robotic systems being used within industry on a more continual basis beyond the POC and demonstrators.
Okay, so yes, I'll try and answer first. And I think generally the answer, unfortunately, is that a lot of the robotics that are being used at the moment, certainly the ones that we're developing, are being demonstrated and are used on site on one-off basis. And that's precisely what we're trying to change. We're trying to develop technologies that we can demonstrate, we can use to increase the confidence the nuclear industry has. And one good example of what we're trying to do, certainly up in Cumbria and working with Sellafield, we've established, or about to establish, a sensor that will be opening shortly, which links Sellafield, NNL, university researchers, and UK AEA to try to develop these technologies in partnership with Sellafield. and to really support those robotic systems as they go on site and as they are used on continuous basis. And we are looking, particularly with support of the UK AEA around some of their drum stores, at being able to deploy these robots on a continuous basis. So fairly safe radioactive environments where we can properly demonstrate these technologies and use them on a day-to-day basis. So that's certainly what we're targeting, but there's a lot to do before robots are really used day-to-day in most areas on site.
Thanks for that, Barry. And Rustem, what's your take on that?
I was slightly uncertain about actually what was being asked. Is it which of the university technologies have got onto site, or the challenge of doing so?
I think it's wider than that. I think the question that was being asked is, once it's gone through proof of concept and that design, has it been available within industry? Have we managed to, is it something that you've managed to progress further?
We had computer vision guided AI controlled autonomous manipulators working in radioactive hot cells with real contaminated material by late 2016, early 2017, working with National Nuclear Lab at the Springfields nuclear site. And we've been controlling heavy duty manipulators with the very, very latest AI autonomy methods at sites such as Workington since 2015-ish, and under full nuclear safety regulation. So that is possible to do, and we've been doing it. I do feel that these technologies could have been perhaps pushed further by the industry. I think the academics have made a lot of effort to meet industry halfway, but it's still quite difficult to go from an R&D demo to something that you could call a working commercial product, and that is a very, very difficult problem for both sides to solve, I would say.
And that's from our perspective, just to give a bit of light on that. I think, Barry, from what you were saying about the collaboration and the kind of work that we're now trying to do within nuclear, I think that will hopefully close a few of them gaps. So appreciate that one. Another quick one from myself. There was a question asked about the videos being available after the session. They are being recorded and will be available on demand to rewatch afterwards on the website, I believe. So that's a good bit of news for you. Rob, I'd like to come to you for a quick question, if I may. Another one from the floor. The presentations are all focused on the excellent work of the academic research hubs. Do you see the skills gaps at a technical level or a collaboration level in the nuclear power sector?
So skills are massively important. And I think one of the things that we're talking about here is scale up. So insertion of technology into industry and scale up. Because, of course, that's the only time you actually make any return on investment. And that's what is needed in order for SMEs to grow. So you have to make them more investable. So we need pace, we need scale up, and therefore you need lots of people. So you need lots of people who are in the, who are working for the end user, but in the supply chain as well, who can have the conversations to transfer the technology from one to the next. So I think about skills as part of the whole conversation that is needed between the supply chain and the user. So we have got to be speaking the same language so that we understand the capabilities, the risks, the procurement practices, all of it, so that we can get into contract faster. So it's the skills piece is much broader than how does a robot work? It's actually the skills about how to adopt and insert technology. So I talk more about setting up a conversation to lead to contracts. And that's something that we're really keen to look at. How can you do collaboration to enable rapid conversation, timely conversation, evidence-full conversation that can get you into contract faster? And that, of course, leads to skills. You have to have the skills on both sides of that conversation, intelligent customer, intelligent supply chain, to make that go as efficiently as possible.
Thanks for that, Rob.
Thanks, Rob. We have another question from the floor. We'd like to direct to John Brotherhoods at Jacobs. So John, this question asks about a lot of great work going on within nuclear, but are the robotic systems that are used within industry on a more continual basis, say for daily operations, beyond the demonstrator phase?
I don't think, certainly within in nuclear there are examples where things are starting to come to that place, but I think we're still very much on a day-to-day looking at the technologies we were using 20 years ago. I think what is changing is that the supply chain is now, and I think it's the really important part, is actually sort of leading on from what Rob was talking about there. The customer is asking, the supply chain is now starting to engage, and there's a follow through starting to come from those bright SMEs with good ideas right the way up through the supply chain to the customer. And I think that's going to change in the next few years.
Brilliant. I've got another one from the floor. I'm not sure who to unfairly pick on with this one because it's quite detailed. I'm thinking Barry, actually. Sorry. And then what I might do is I might get in a supply chain member, possibly yourself, Matt. That's all right. So the question is, for the nuclear projects, what's the kind of data that is used for it? AI and machine learning. So from my perspective, before we go in there, we're looking at the minute, we're very much teleoperational in a lot of the respect that we do because of the high hazard, high consequence environments within the nuclear environment itself, the extreme environments. We are looking at going towards human supervised autonomy to full autonomy down the line, especially when we go for digital twinning and decommissioning through them kind of approaches. But Barry, first of all, I'd like to come to yourself. What's your thoughts on what's the pipeline that you can sort of see to sort of tailor this in so we can go from where we are today, teleoperational, through to the acceptance for full autonomy or semi-human supervised autonomy?
Yeah, so I think it's not something that's suddenly going to be introduced overnight. I think it is a gradual process, and that comes from setting up robotic systems that are teleoperated and then gradually introducing support for the operators so that they can do they can manage these robots faster. So Rustem's done some great work, for example, on grasping objects and automatically grasping objects, and that takes that away from the operator. So the operator still has full control, but when it comes down to some of the low-level detail, then we can start to make those systems automated. And then as confidence increases in these machines, I think it will naturally be that it'll be driven more by the operations staff who will want things to be more automated. The thing that we have to bear in mind with this, though, is that we still need to make sure that we can verify and validate the robotic systems. And that's something that we are working on within the Rine Hub. And how can we implement automation and autonomous systems, but still make sure that they do exactly what we want them to do. And that is still a challenge.
And that's the key, Barry. It's giving that confidence to make sure that it's still safe and it still does as we ask. Even in a fail-safe situation, we need to be able to demonstrate that. Matt, what's your perception of that?
So I interpreted this question as being about where do you get the data from to train your AI system? I think that's what the questioner was getting at. And I think the honest answer is that right now we basically can't use AI in nuclear for any situation where the data is nuclear specific, i.e. it's something to do with radiation or waste or what have you, because we don't have the data. And the strategy is the one that Barry was just alluding to. We need to find applications that aren't AI, that do generate the data, that then enable you to put the automation on top of that system. So I think there's a trajectory where we begin with full teleoperation and then transition piece by piece by automating the bits that are currently being doing manual, but it actually starts with the data, and that enables the rest of the trajectory.
Brilliant, thanks, Matt. I'd like to come to Barnon, if that's all right, because some of the path planning elements that you did in the ConnectR use AI, don't they? How did you find that?
Correct. Yeah, I'll hand you over to George. Sure.
Yeah, hi there. So we worked a lot. One of our consortium members was actually Royal Holloway University, who developed a really great symbolic planning system for ConnectR. But yeah, basically how it works is we take a scan, a point cloud, and that gives us an environment, and we can build an environment around that. So that's the data. But then we also take other data around things like the strength of the superstructs themselves and the moves that are possible. And we give that as a set of rules to a planning system. So rather than using machine learning, we just tell it what it can and can't do. And then it can build a plan of a structure from that point. So that's quite good because it gets rid of around some of the kind of industry sort of worry around things like machine learning. And also we're able to basically have a human in the loop. So after every step, we can just say, yeah, that's okay. So yeah, that's how we're doing it with ConnectR.
And that's the key, isn't it? It's getting that confidence, keeping that human in the loop to have that last sort of say, actually, I'm happy with that, or, you know, I'm not, let me manually have a look at it. And I think that's the key to how we do that eventually. That's actually quite good. Thank you for that. JP?
Thanks, Chris. So next we have a question for Peter Rowledge at Forth. So Peter, how do you work with government procurement processes to deliver these great technologies?
In terms of how the Forth work with these government processes at the moment, it's through a bidding process. So most of the work that Forth procures is through either a tender process. We're working on one in our feasibility study that was a tender process. So as I alluded to before, there's a lot of SMEs in the supply chain that are expert at innovation, but it requires them to be able to write a tender process as well. So through the tender process, and then, as I said, now we're either doing an active demonstrator for Sellafield to take it to a medium TR level, or it's through a feasibility study and then extra funding to take it to the next level. So how can the government processes be more streamlined? I think bringing greater application, and as other colleagues have alluded to, it's about the speed of the process as well. We need to speed up the process from an SME point of view. I was talking yesterday about a particular challenge on Sellafield, but they're not wanting the results for 3 years. Now, 3 years for an SME is a long time, and an SME can be out of business if that process doesn't happen within them timescales. So government processes need to speed up to enable SMEs to deliver the solution and then provide Sellafield with a solution to their particular challenge as it stands at the moment. If we know we've got a challenge, then try and let us solve the solution for you. And it's actually great collaboration between more partners. Sellafield all that challenge and providing a swifter government process to enable companies to provide that support to Sellafield and so on.
Right.
That's great. Thank you, Peter. Well, we've come to the end of the panel session. Thank you once again for all the organisations providing those videos and for the panel joining, and for all the participants who asking those questions on the chat. So we'd like to invite you all who joined the panel and the attendees to join us in the collaboration session. So you can join that by going into the attendee hub, head into the all sessions tab, and then click on the relevant session to join us there. So you can network with any other attendees and also all of us and ask any more questions of all the panel as well. So with that, thank you once again, and hope to see you again soon.
Thank you.